write it all out again. This is what?
V0.
V naught cosine theta t. This is V naught sine theta t minus 1/2 gt squared. I don't need the plus h naught because it's from the origin, right?
Mhm.
All right. I want to talk about a formula for x. Can we find a formula for x, which would be the distance, right? All right, well, let's start out. Like right there, the distance that would take for this thing to hit the ground. So what would the y component have to be?
0.
0. Let's start with that. So that's what we're doing. We're going to explore to figure out a nice, simple formula for what x could equal. You go, well, it's equal to this. Yeah, but look, it's got a v naught variable, it's got a theta variable, and another t, right? We got to know all these different values. So I'm going to start with this. In order to hit ground, what's the y going to equal?
0.
So I'm going to write 0 equals v naught sine theta t minus 1/2 gt squared. We are just exploring another formula that you and I can create on our own to make these problems way easier to deal with. Here, I'm just going to point it out. Make these easier for us, could you? And what we'll do is we'll figure out another formula to use. So and if this is when it hits the ground, right? The y component equals 0. Can you help me factor this? What can I factor out? The t?
T, yeah.
And then what are you left with?
V
V
naught.
naught sine theta minus 1/2 gt. Right? So let's focus on this second one. Can you solve for t here? We're deriving a new formula, which is good for problems 25 and 27. What would t equal to if this equals 0? Ignore that one because t just equals what right there?
0.
All right, yeah, we know that. That's when it was here. T equals 0. We want this t. What would be the time it takes for it to travel the distance x?
So
Okay, so what would t equal if you solve that? That equals that. Isolate the t.
T equals to V naught sine theta divided by 4.9 G.
Okay, all right. Sounds good to me. I'll add this over here to this side, and I heard you say
V naught sine theta.
it equals this, so I can multiply the 2 over here and then divide the g. Sound agree? 2v naught sine theta all over g is equal to t. And where can I substitute this? This is going to what variable?
T.
Are you ready? So in our color code, look. This is now going to get substituted in this. We're going to make a formula for x. What is x equal to? This is for these two values. It looks like I've got x equal to a v naught cosine theta times, put a big parentheses, and jam that in there. And we're almost done. Put all that in there. What would that be? 2 v naught sine theta. Another reason I want to derive this with you, I sometimes forget this formula. So I go through this. I know it takes about a minute. You're like, let me go figure this out. Almost done. Just simplify this. Then I just put that right there coming from here. This will be our formula for x if it's thrown or launched from the origin. For the distance x that this traveled, whatever it is. Right? Doesn't have to be a golf ball. It be something in the military. Alright? What's v naught times v naught?
V naught square.
Put a square on that.
Then
You got a 2 in there.
can
You got a sine theta
cosine theta?
and a cosine theta, and it's all over what variable?
G.
G, which really is a constant.
But don't you have a trig guide 2 sine A, sine B?
You got a good eye. What do you spot?
The trig identity 2 sine
He
theta.
spots a trig identity. Does anyone else see this? So we're going to use it. This is equal to, it's a trig identity. There's a double angle identity for this. And what's that equal to? You got it. Sine of 2 theta. And there it is. Everyone, please only use this great formula you and I derived. Thank you for being patient with me. I know it took a couple minutes. But boy, this is going to make these two problems way easier. I hope even when you do them on your practice set. Because we took the time to derive this. You broke this down, everyone. Do you see any t in there?
No.
Look, the t got eliminated. We eliminated it. But only use this if it's launched from the what?
Origin.
Origin. So let's do these two problems from the book. Okay? But use this. This is great for things being launched from the origin. I couldn't do this with Aaron Rodgers. I would have. Because Aaron was 2 meters up in the what?
Yeah.
Air. All we figure out is when it was 2 meters from, right? That's distance x. Distance, okay. Well, I'm gonna leave that on the board. Can I erase the derivation? Cool. All right, well, here comes the questions. I'm not going to use that. I'm going to use this. Number 25. When I read this to you, feel free to draw a picture. This is what they said. They go, a ball is thrown at an angle of 45 degrees to the ground. If the ball lands 90 meters away, what was its initial speed? So all that wording, let's just draw a picture. 45 degrees, 90 meters, it lands. You got to find this. The initial speed. Cool. Oh gosh, if I went in here, I could have done the substitution, but we got this now, right?
Mm-hmm.
Let's use that. Here I go. What's the distance?
90.
90 equals
Then
9.8 squared. And you go, no, 9.8 is the what?
you need to
The
multiply.
G.
We need to
What's the
multiply.
initial speed? I don't know. That's my unknown. That's 9.8. And a sine of, what's 2 times 45?
90.
What is the sine of 90?
1.
So I'll multiply this on both sides. On the sine of 90 is 1. Right? Sine of 90 degrees is 1. And what do? How do you get V0?
Square root.
Square root of this. Hey, what's 90 times 9.8 on a calculator?
882.
And what's that? Square root of that?
29.7.
29.7?
Yep.
Meters per? Almost 30 meters per second, right? An initial speed was like 30 meters per second. So this formula, great from anything being launched from the origin. Helpful for problems like this, you'll see it at the end of the practice set. And one more, let's do one like 27. Let me read it to you, and I'll erase this. But they go, a gun has muzzle speed 150 meters per second. Find 2 angles of elevation that can be used to hit a target 800 meters away. So I'll repeat that. Let's erase this one, but let's use this again. So this is 27 from the textbook. Read it again. A gun has muzzle speed 150 meters per second. Okay. Secondly, find 2 angles of elevation that can be used to hit a target 800 meters away. So x will equal what? 800 meters. But they want 2 angles. So when we're looking at something that kind of goes like that, but maybe another angle that goes like that, right? Awesome. Find the 2 angles of elevation that can make this happen. Let's start here. What's 800 equal to? 100 and, oh, that's a 50. 150 squared divided by 9.8 times sine of
Theta.
2 theta, correct?
2000.
So let's isolate that sine 2 theta. What's sine of 2 theta equal to? Well, whatever 800 times 9.8 all over 150 squared. You'll see one like this on your practice set. Okay. Cool. I get sine of 2 theta equals, what do y'all get?
3.48.
0.3.
3.48.
Well, it sounds like you're 1 decimal off. Do you agree? The highest sine can ever be is
Sorry.
what? 1? I just caught that. I was like, oh, it's going to give us an error. Because this number that comes out here has to be between 1 and -1. I would agree.
0.348, yeah.
0.3, was it 0.48?
No, just 48.
Oh, no, 0.348. Thank you. So, he's got this. So I'm going to be careful here. So some angle, 2 sine of 2 theta equals this. So 2 theta must equal inverse sine of 0.348. Sure?
Mm-hmm.
So 2 theta must equal, let's see what we get. What's the inverse sine of that?
20.39.
Okay, 20.39. Now be careful. Is one of the answers 20.39? Oh, you gotta go back to degree mode now, if you're in radian mode. Is one of the angles 20.39 degrees? No, I have to divide by what?
2.
The 2. So what do you get?
10.20.
Yeah, let's go to 1 decimal place. 10.2 degrees. All right, we got one. But they want how many?
2.
2. Everyone, we're gonna use that all students take crack thing. You know what I'm talking about? All students take crack.
Uh-huh.
Like in here, all trig functions are positive, but sine's also positive what? Here. So do you all know about this relationship? Like the sine of 40 is equal to the sine of 140. The sine in terms of supplementary angles. The sine of 30 is equal to the sine of 150. The sine of 60 is equal to the sine of 120. I can keep going all the way up to the sine of 90 equals sine of 90. Well, the sine of that angle is equal to the sine of, what's 180 minus that?
Something
What's
like
180 minus that number?
169 something.
169.6 or something, is that 0.6? Right? Alright, what's theta then? What's the other angle? You can check this too if you want. Here's the other angle. I'm just using that idea of supplementary angles with this sine because of how it's like, yeah, the sine of theta is equal to the sine of 180 minus theta. What do you get here?
But 85 something.
79.2? No, 0.8? Is that right? I just checked to make sure these should have the 90 actually. You can check that. Was it 2x? Hey, that was like, looking at the practice set. Oh, that was like numbers. Oh, let's see. Number 41 and 42, the last two problems. So cool. Man, we did all this stuff. Any questions on any of this stuff? I do want to point out this section, it did give you more practice refining the speed, which is just the magnitude of velocity. If you want to practice drawing those the velocity vector and acceleration vector, they gave us a couple problems on that. Like even number 5, they drew that stuff out. You know, I'm thinking we should do that last, everyone. I should go back to one of these problems where you had to draw the path. Not even using this, not the motion paper. I'm talking about just draw the actual path of something because I noticed it had a cosine and a sine in there. I'm just going to make this up. And if you had to draw this path, I can make a table, right? What's going on at t equal to 0? That's 2 and that's what?
0.
And I think you all know what kind of path this is made. Think of what x squared plus y squared is. Just think of it. I made up this problem, everyone, but I just want you to see, oh, you got to sketch the path of this in two-dimensional space. You go, oh, okay, this is different than this then, right? So this is like number, they put a problem like this around number 5. So I'm going to put that, what's going on at pi over 2? That's 0, that's 2. What's going on at pi? That's -2, and this is what? 0. So does anyone see the path this thing just took? Alright. Let me draw this to scale up. Alright. And if I continue this path all the way out to 2 pi, what does it really make?
Circle.
You all notice it? X squared plus y squared equals 2 squared. And what's the radius of this thing?
4.
And traveling that path, so I just want to make sure I get this all drawn so it looks halfway decent. When there's the path, I'll put an arrow this way. There's the path. Alright, I was just curious, if you had to draw the position vector at something not even over here, like at pi over 4. Could you do that? So what's going on at t equal to pi over 4? Could you draw the position vector? So what would be r of pi over 4? Let's just see. Plug in pi over 4. What's 2 times cosine of pi over 4? What's 2 times 1 over the square root of 2?
So that should be 0, right? Pi over 2.
Or 2 times square root of 2 over 2 would just be that, right?
Okay.
What's 2 times sine of pi over 4? What's 2 times square root of 2 over 2? Square root of 2. But where would this be located?
And
Oh, I'll use this right here. That's the position vector right there. Sound cool? I just chose, some time value. How about t equal to pi over 4? All right, that's r of t. And you know where I'm getting to. I just want to, well, what if you got to find r prime of pi over 4? There's another name for this. We call this the velocity vector, right?
Mhm.
If you got to find the velocity vector and then draw it, it should be a tangent vector, shouldn't it? And the tangent should go in the path of that particle. So remember it's traveling this way? You should notice you get a vector like this. You want to see it? What would it be? What's the derivative of this? First I'll do v of t. And then I'll do v of pi over 4. So what's v? Here, I'll get this out of the way. What's v? And this is for r prime, which would be the derivative of that. What's v of t?
negative 2 sine t.
Negative 2 sine t.
And
2 cosine t. Now, can you plug in pi over 4? Okay. Plug in pi over 4 and you get
negative.
negative 2 times square root of 2 over 2. 2 times square root of 2 over 2. And sure enough, how did this move? This vector did what right here? It went negative square root of 2 that way and square root of 2 this way, and it looks like that. And right there. That's the b prime. Now one more. Can you find this one? Can you find the acceleration and then the acceleration vector at pi over 4? And I wanted you to see acceleration